All right, so we're going to look at a probably year 9 level linear relations problem where we have a negative gradient. So, and we're going to model a real world situation. So if we look at this question, it says that there is a leak in a rainwater tank that has a volume of 1,000 liters. Initially, the tank is full. 50 liters leak out of the tank every 2 hours. So the first part we have to do is create a table of values that shows the amount of water in the tank for the first 12 hours. Okay, so along here, we're going to have time in hours. These are our two variables, right? And we can have 0 hours, after 2 hours, after 4 hours, 6 hours, 8 hours, 10 hours, 12 hours. Now you could have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, but just because it says that every 2 hours, I'm going to do this by going up in twos. So the volume is in liters. Okay, it says initially, so that means at time 0, the tank is full. So this has to be 1,000. After um, after 2 hours, it goes down by 50. So what's this? It's going to be 950. And then it's going to be 900. It's going to go down by 50 every 2 hours. So it's going to be 850. It's going to be 800. It's going to be 750. And after 12 hours, it's going to be 700. Okay, so that's our table of values. Now use the table of values to plot the graph below. Using a ruler, draw an appropriate line. So when it says draw an appropriate line, that means you need to keep your line going in both directions. Don't just draw a line segment between 2 points. So what we're going to do first is we're going to put 2 points on. One of the points is that when time is 0, so we've got time on the x-axis on the bottom, on the horizontal axis. We know that the volume is 1,000, so that's there. Okay, after 2 hours, we know that the volume goes down to 950. After 4 hours, it goes to 900. So maybe I'll put the 4-hour one in. So that would be there somewhere, right? Okay, and then you got to do your best to draw a line. And I'm going to try and use a ruler here as best I can. So about there. And that is definitely not right. Just erase that. Because it's important we use a ruler because once we connect these points, it's going to show us all the other points that would be on the line. And that's no good. Anyway, I'll try and draw it roughly by hand. So let me try that. Actually, let me pause and I'll do it properly. All right, so we get a line that looks something like that. And that's drawn very accurately. You'd be doing well if you could get it that accurate. But yeah, that's what it should look like. Okay, create a rule that relates the volume of water in the tank and the time in hours. So V for the volume and T for time. Now, if we think back to what we've learnt in previous lessons, we know that whatever's on this axis, on this y-axis, the vertical axis, is going to be our is going to be on the left-hand side of the equation. So we're going to say V equals, okay, it's the gradient. Now we need to be careful what the gradient is here. It's going down by 50 each time. But strictly speaking, the gradient is how much it goes down every time the horizontal axis increases by 1. So you can hopefully see that the time axis is actually going up by 2 each time. So we need to think, well, how much would the volume go down if we increased by 1? So let me explain. Hopefully you could see, and I'll do another example here. If we were to go to the 13th hour, well, if it goes down 50 liters in 2 hours, then it must go down 25 liters in 1 hour. So we can see that this would actually be, this next one here would be 675 if we went down by, so if our time increased by 1 hour, our volume would go down by 25 liters. Okay, so that's actually important. That's an important concept. So what we're actually going to say is it's going down by 25 liters every hour. So multiply that by the time. Okay, and then we have to find out where our y-intercept is or where our volume intercept is. So we have to, where we started was at 1,000. Okay, so this would be our rule. The volume of the water in the tank is equal to negative 25 multiplied by T plus 1000. Okay, so how much water is left in the tank after 16 hours? So we're going to do volume equals, I'm just going to substitute in 16, and then I'm going to add 1000. Okay, and negative 25 times 16. Let's do it. Why not? If you had to do it without a calculator, you would do 25 times 16 multiplied by 16. It's that 30, carry the 3. 6 times 2 is 12, plus 3 is 15. Right now we're in the tens column, so we have to have this magic 0, but it's because we're multiplying by 10 now. So that's a 5. 1 times 5. 1 times 2 is 2. So what's that? 0, 0, carry the 1. It's that 400. So 400. Does that sound about right? Yeah, that sounds about right. So 400 plus 1000. 400 plus 1000 is 1400 liters. Now, do a sanity check. Does that make any sense? No, because there's only 1000 liters in the tank to begin with. So hopefully you noticed what I did wrong. I forgot in my thing here that I was actually multiplying by negative 25. So this is negative 400, isn't it? So let's just chuck the negative in there. Okay, so the whole thing's negative 400. So this is negative 400 plus 1000, which is 600 liters. So how much water is in the tank after 16 hours? So it'll be 600 liters. And let's just go look at our graph. 16 hours, 600 liters. So that looks about right there. How much water flows out of the tank in 1 hour? Well, hopefully, if in 2 hours there's 50 liters goes out of the tank, in 1 hour there's going to be 25 liters out of the tank. Okay, and this is assuming that the whole thing is linear, which it is. After how many hours will the tank be empty? Okay, if you drew your graph perfectly, you can see that it's going to intercept the x-axis or the time axis after 40 hours. There will be no water left in the tank. However, if you drew your graph not perfectly, which, it took me a long time to get that graph perfect, reading it off the graph could be inaccurate. So you need to be able to use the rule to determine after how many hours the tank will be empty. So basically, this is a situation where you're going to substitute the left-hand side being 0. So we're going to say, all right, the volume is 0. So it's going to be negative 25 multiplied by T plus 1000. Okay, now basically we're asking ourselves, some number multiplied by negative 25 plus 1000 equals 0. What does that number need to be? Well, you can do trial and error, but this is where we can use a little bit of algebra. So we can say, all right, if I took some number, T, and multiplied by negative 25, and then added 1000, well, I can just undo those things. So I can take 0 minus 1000, so subtract 1000 from both sides. Gives me negative 25T multiplied by T. Okay, and then some number multiplied by negative 25 equals negative 1000. Let me simplify this. So negative 1000 equals negative 25T. Okay, when we put them together, it just means multiplication. All right, so T equals negative 1000, divide both sides by negative 25. Okay, 1000 divided by 25. How many times does 25 go into 1000? Let's think. 25 goes into 100 4 times, so it's going to go into 1000 40 times. And remember, when you've got a double negative, when you've got a negative here and a negative here, and you take division of two negative numbers becomes a positive number. So after how many hours will the tank be empty? It will be after 40 hours. Okay, what is the rate at which the water is flowing out of the tank? Include units in your answer. Okay, this is this idea of gradient. So basically, how steep is this line? And let's do it. So if you're unsure about how to do this, what you do is you create a little triangle and you work out rise over run. So let's go down to, let's do this example we had before. You can make any triangle you like as long as it's between 2 points. Okay, so this point here is 0, 1000. And this point here we said before was at 16, 600. Okay, and hopefully you're already starting to think what the gradient is. In fact, I think we pretty much already answered what the gradient is. Let's work out the run. The run is 16. Okay, and this length here is the rise. So we go from 16 to 1,000. So this is a rise of 400. Okay, now remember rise over run. Rise over run tells us the gradient. Okay, but now with this negative example, we need to be careful. We need to think about where we're starting and where we're finishing. So let's start here and run down this way. So if I go down in this direction, I'm actually going negative 400. Hopefully you would agree with that. So, the rise, I won't change it, but what we'll say is the rise is negative 400 and the run is 16. Okay, 400 divided by 16. You're welcome to work it out, but I can tell you that it's negative 25. Okay, and that should all hopefully come together because we said the gradient earlier was negative 25. But now the question says, what's the rate? So we would say that the rate, and this should hopefully make sense, is negative 25 liters per hour. Okay, because it says include units. And remember, rise over run. Well, along the rise axis or the y-axis, we have liters, and on the x-axis we have time, we have hours. So you have to take the units that were on the y-axis, which is liters, and divide by the units on the x-axis, which is hours. So you'd say that the rate at which water is flowing out of the tank is negative 25 liters per hour. And so this is an example where we have a negative rate of change, and that rate corresponds to our gradient. Okay, hopefully that clarifies some of those negative linear relation problems. Good luck.